Hello student, good morning. Today we are learn about a new topic electric potential. In the last classes we learn the properties of electric charge and its behavior around it, and we discussing or understood about the electric field, and also we are learn about Gauss's theorem and some application based on the Gauss's theorem and how the Gauss theorem applied on different kind of shapes. Now in this lecture or from today we are understood about the next characteristic of electric charge, that is a scalar quantity and known electric potential or electrostatic potential. Then we understood the representation or derivation or the formula of electric potential, and then we are also relate the electric potential with electric field, and then after we discussing about the energy stored in the capacitor beside it. Okay, now the first topic is electric potential. Electrostatic potential. This is the characteristic of electric charge. This is the characteristic of an electric charge around it. That is, suppose student, we have Q charge placed at point O, and this is a point A, and at infinity there is a test charge Q naught is placed. Okay, now the electrostatic potential around this charge is understood by this way. Suppose an external force is applied by on this Q naught charge or positive test charge, and the work done by that force to bring it in the field of this charge or against this charge, because this is a positive charge and this is also a positive charge, then they repel each other. So the external force is work against the force of this charge or electrostatic force. Okay, now the amount of work done, suppose this Q naught charge is bring with the help of the external force to point B. Okay, now when it reaches at point B, it experiences the field of another charge. So we are discussing about the potential due to this charge at point P. Thereafter, when we carrying the charge from point B to A from r meter distance from the original or the initial charge plus q, then we discussing about the difference between the potential at point B and at point A. This special quantity is called potential difference between 2 points, which is given by the work done, the amount of work done bring the unit positive charge from point B to point A. Now first we discussing about the electric potential. Now what is electric potential? So electric potential, electrostatic potential, potential is defined as amount of work done to bringing a unit positive test charge Q naught from infinity to a point. Okay, that is electrostatic potential is equal to W upon Q. It is be taken as infinity to B, or simply we are written as W upon Q naught. So the potential is W upon Q naught, where W is work done to bringing a unit test charge plus Q naught from infinity to a point B. Okay, SI unit of electric potential V is joule. Here student, joule per coulomb, that is this. It is also known as, also called volt. Okay, this is a derived unit, and its dimensional formula is, okay student, you all know this is work done, and work is energy, and energy has dimension m L2 T minus 2. Okay student, and Q is I into T. Okay, now I has dimension A and T has dimension T, so we are using here A T. Therefore we are getting the dimension of potential is ML2 T minus 3 A minus 1. This is the dimension. Student, because it is here, charge is a scalar quantity and we know work is also a scalar quantity, so this potential is also a scalar quantity. Therefore electrostatic potential is a scalar quantity. Okay student, now copy this note. Then we go to understood about the potential difference, and we derive a formula for the electrostatic potential at a point due to a point charge. Now first we define the potential at a point is 1 point, or definition of 1 volt. 1 volt. We have, student, potential is equal to W upon Q. The potential is become 1 volt if the work done is 1 joule to bringing a unit positive test charge 1 coulomb. Okay, now electric potential 1 volt is that electric potential when amount of work done is 1 joule to bringing a 1 coulomb test charge from infinity to a point. This is the definition of 1 volt. Copy this. Okay student, the next topic is electrostatic potential difference. Now, when the positive charge is carrying at point B and a force we applied or we have done work from B to A against this positive charge, then the potential at point VA and the potential at point VB and the potential at point VA gives the value of the potential difference from VA minus VB. This is called electrostatic potential. Now we define first the electrostatic potential, and this VA upon VB, we are also using the form like this. Suppose a test charge is moving around a circular path from point A to B. Therefore, potential at point A is VA and potential at point V is VB. Therefore, the potential difference VA minus VB is equal to work done from B to A on the test charge Q. So this is given by V potential difference across the point AB is equal to W AB upon Q naught. Now student, first we define and then we write the formula. Electrostatic potential difference potential difference is defined as the amount of work done to bringing unit positive test charge between 2 points. Okay, it is given by VAB that is VA minus VB is equal to WAB upon Q naught. This is the electrostatic potential difference, or simply we call potential difference. Its SI unit is volt or joule per coulomb, having the same dimensional formula ml2 t minus 3 a minus 1. Okay, and potential difference, unit of potential difference is defined as 1 volt potential difference. If 1 joule of work is done to bringing a plus 1 coulomb of charge between 2 points, then potential difference is said to be 1 volt, is called 1 volt. This is the definition of 1 volt in the form of potential difference. Copy these notes. Okay, student, now we go to derive a formula for potential due to a point charge. Okay, therefore consider a point charge plus Q at O. Okay, at infinity a test charge Q naught is kept. The potential at point A at point A due to charge plus q is calculated is okay student. Now this is plus q charge and we need to calculate the potential at point A at a armature distance. Let the q naught charge is placed, a test charge q naught is placed at infinity, and when we try to move this positive test charge from infinity to towards point A, therefore in between infinity to point A we are taking a point M, and the point M is a distance of x from the test charge. Okay, let from M to point B a small distance dx is covered influence of the force against the positive charge. This is the repulsive force because the test charge plus q, point charge plus q, and test charge is also positive. So like charges repel each other. Therefore we do some work against this influence of the electrostatic force applied by the point charge on this test charge. Okay, now let us start moving a test unit charge infinity towards point A, which is at r distance from charge q. Now let M be a point at a distance x. This is from charge q to M, x distance. Now a force of repulsion on q naught charge 1 coulomb due to charge q is given by F is equal to 1 upon 4 pi epsilon naught q upon x square. Because q naught has value 1 coulomb, therefore 1 upon 4 pi epsilon naught q upon x square. Okay student, now small work done from point M to B. Small work done from M to B is dW is equal to F into dx. Okay, so dx is in the direction opposite to the force. Therefore this is minus 1 upon 4 pi epsilon naught q upon x square dx. Therefore total work done to bringing q naught charge at point A is W is equal to integration from infinity to point A is equal to distance r is dW, and it is minus integration infinity to r 1 upon 4 pi epsilon naught q x square dx. Now student, these value is constant, therefore work minus 1 upon 4 pi epsilon naught q is infinity to r x to the power minus 2 dx. Okay, now this is gives the result minus 1 upon q upon 4 pi epsilon naught integration 1 1 upon r to infinity to r. Here integration of 1 upon, we are using x square dx minus 2 is x to the power minus 2 minus 1 upon minus 2 plus 1, which we get x to the power minus x upon minus 1, which gives us result 1 upon x in negative form. Okay, now on taking limits, we are finding this work done is equal to minus q upon 4 pi epsilon naught minus 1 upon r 1 upon r minus 1 upon infinity. Now the value of 1 upon infinity is 0, therefore minus minus plus, we get work done is 1 upon 4 pi epsilon naught q upon r. This is work done, and this work done is okay. We are not taking here, it is 1, so we have this is q naught also, q naught, here we have q naught, here also q naught. Now this is work done. Now the electrostatic potential at a point, electric potential at a point is V is equal to W upon Q naught. Now the value of W is 1 upon 4 pi epsilon naught Q naught capital Q upon R into 1 upon Q naught. This Q naught is cancelled. So the potential at a point due to a point charge V is 1 upon 4 pi epsilon naught Q upon R. This is the potential due to a point charge. Copy these notes. Okay, student. The VR graph, when we plot the VR graph, so from the formula we are finding the potential the potential is inversely proportional to R, and student, electric field is inversely proportional to R square due to a point charge. Now the graph which we call VR graph, potential distance graph. This is distance and this is potential, and we relate this graph with the electric field also. We find the potential is depleted slower than the electric field. This is the depletion of electric field. So this is V is proportional to R, and this is E is proportional to 1 upon R square. Just copy this graph. That is, the potential is deplete slower than the electric field due to a point charge. Just copy. From the graph, the value of electric field is deplete faster than potential. Okay. Now we are taking the potential due to many charges. Consider n charges Q1, Q2, Qn are distance from R at distances R1, R2, Rn respectively in free space. Therefore, potential at a point is V1, V2, V3, Vn. We have potential at a point 1 upon 4 pi epsilon naught Q1 Q upon R square. Therefore, potential is Q1 upon 4 pi epsilon naught R1, Q2 upon 4 pi epsilon naught R2, and similarly Qn upon 4 pi epsilon naught Rn. Therefore, the potential due to many charges is 1 upon 4 pi epsilon naught summation R is equal to 1 to R is equal to N R equal to Q equal to 1 to R equal to Q equal to N is Q upon R. Or we also taking this I to N, that is थोड़ा सा छोटा कर देते हैं इसको, समीशन I is equal to 1 to I is equal to N, and we are using here Qi upon Ri. This is the potential due to many charges at a point. So copy all these notes. We are closing today.